Way back in 1905, Albert Einstein was having a pretty big year. He discovered that light was carried by particles, figured out the rough size of an atom, and concluded that the speed of light is always the same, no matter where you are or whether you're moving. Einstein's most famous discovery of that year, however, was that mass and energy are basically the same thing. We know this as E equals mc squared, where E equals energy, m equals mass, and c is the speed of light. But what exactly does that mean? First, it means that every object that has mass also has a ton of inherent energy, even if it's not doing anything. But before you think all our energy problems are solved, this energy is very hard to get to. Chemical processes only convert about a billionth of an object's mass, and even our sun, which runs on nuclear fusion, has only converted 0.03% of its mass in 5 billion years. In fact, the only way to convert an entire object into energy is to create an antimatter version of the object and smash the two together. However, since it's hard to create a very large antimatter anything, it's not really useful to power, say, a city. And speaking of creating antimatter things, E equals mc squared also means that if you can convert mass into energy, you can do the opposite too. In particle colliders, for example, we give particles a ton of energy and accelerate them to almost the speed of light. Then, we smash them together, and boom! New particles are created from the energy released during the collision. We've discovered new particles like the Higgs boson that way, and we've also figured out ways to produce lots of certain kinds of particles for scientific use. Finally, even though we've been talking a lot about mass, E equals mc squared also accounts for particles that have no mass. These particles, like photons, always move at the speed of light and exhibit all their energy as kinetic energy, or the energy of motion. If you could stop a photon, it would simply cease to exist. However, even with no mass, photons can still add mass to a system. If an atom absorbs a photon, for example, the atom gets just a bit more mass, even though the photon itself has no mass, and that's just kind of mind-blowing. So all in all, while Einstein's great year in 1905 gave us a ton of new things to chew on, the idea that mass and energy are equivalent really stuck, giving us the possibilities of converting mass into energy and back again, particles without mass, and more. But most importantly, it ultimately gave us a simple little equation with massive implications.